chance to practice the mechanics of linear programming and see how it works, you want to answer one of those age-old questions in mathematics. When am I ever going to use this? We'll look at 3 examples of problems that could be solved by using linear programming. Here's the first one. An office manager needs to purchase new filing cabinets. He knows that ACE cabinets cost $40 each, require 6 square feet of floor space, and hold 8 cubic feet of files. On the other hand, each Excello cabinet costs $80, requires 8 square feet of floor space, and holds 12 cubic feet. His budget permits him to spend no more than $560, while the office has room for no more than 72 square feet of cabinets. The manager desires the greatest storage capacity within the limitations imposed by funds and space. How many of each type should he buy? Okay, this is a very classic type of linear programming problem. We want to get the best bang for the buck. So we're going to start by setting up a table with all the information that we know. So I'm going to start with the 2 file cabinets, ACE and Excello are the brand names. And then we'll make a line down here for the max available. And we'll start with the number. This is what we're trying to find out, how many of each. So we'll say ACE, we're going to get X, and Excello will be by Y. And then my next column, I'll make these a little bit smaller, is cost. ACE cabinets cost $40. Excello cabinets $80, and I don't want to spend more than $560. Space. The ACE cabinets need 6 square feet, the Excello 8 square feet, and the total has to be 72 square feet. And then the last category is capacity. ACE cabinets will hold 8 cubic feet. Excello cabinets hold 12 cubic feet. And this is what we want to maximize. So now we've got our information set up in a table, and we can use the table to write some constraints. Okay, the constraints are going to come in the form of money constraints and space constraints. So I will say that 40x plus 80y, which would be the money, has got to be less than or equal to $560. So that's this column. Now the space, 6x plus 8y has to be less than or equal to 72 square feet. Okay, number of cabinets cannot be negative, nor can the square feet be negative, so we automatically have x has to be greater than or equal to 0, and y has to be greater than or equal to 0. We're going to buy some cabinets, so those won't both be 0. Okay, and then our objective function is going to come from this capacity. That's the thing we're trying to maximize. So we want to say z is equal to 8x plus 12y. And we want to maximize this. Okay, so now we're ready to draw a graph of the feasible region. Okay, to make this a little simpler, I'm going to divide this inequality by 10. Since all of those end with a 0. Okay, and we can graph pretty easily by intercepts. For this first inequality now, if I let x be 0, then I have 8y less than or equal to 56, so that means y must be 7. So 1, 2, 3, 4, 5, 6, 7. And then if I let y be 0, then x is going to be 14. So 10, 11, 12, 13, 14. Out here a little ways. Okay, so that is our money equation, or inequality. On this one, if I let x be 0, then I have 8y less than or equal to 72, so that would be at 9. And if I let y be 0, then x would be equal to 12. So about 11, 12 here. So there's my other constraint. And of course I've got to be up above the x-axis and to the right of the y-axis. And if I had drawn this a little more accurately, the lines would have crossed at this point. And what is that point? Let's see if we can figure it out. I'm going to reduce these again as much as I can. So I have x plus 2y less than or equal to 14. And let's just go with equals because we're trying to find an intersection point. And this one I could reduce by 2. And just have 3x plus 4y equal to 36. Okay, I'm going to multiply that first equation by -2. So I'd have a -2 there. This 2 is now -4. And 14 becomes -28. So now -2x and 3x is going to be just x. These cancel out. -28 plus 36 is 8. So x equals 8. And now let's find y. Going back to x, which we know is 8. 8 plus 2y equals 14. So I subtract the 8 and I get 2y equals 6. So y equals 3. So this point is 8, 3. And we'll adjust our red line to fit that a little better. Okay, so I've got one corner point here. And my other corner points are going to be up here at 0, 7. And out to the side here at 12, 0. Which of those is going to maximize my objective equation? So for this one, I'd have 8 times 0 plus 12 times 7 is 84. And then for the 12, 0, I'd have 8 times 12 plus 12 times 0, which would give me 96. So this one's better of the two corner points. And now we're going to look at 8, 3. 8 times 3, I'm sorry, 8 times 8 plus 12 times 3. Well, that's 64 plus 36, which gives me 100. So this point here, the 8, 3, is the one that's going to give me the maximum capacity of storage while meeting the constraints of the problem. And pause your video now and work on checkpoint 1. In the next problem, we'll be looking to create a feed mixture for some lab animals that meet certain criteria. Certain laboratory animals must have at least 30 grams of protein and at least 20 grams of fat per feeding period. These nutrients come from food A, which costs 18 cents per unit and supplies 2 grams of protein and 4 of fat, and food B with 6 of protein and 2 of fat and costing 12 cents per unit. Food B is brought under a long-term contract requiring that at least 2 units of B be used per serving. How much of each food must be bought to produce the minimum cost per serving? Once again, we're going to start by creating a table to organize our information. So on the left, we'll have the kinds of food, A and B, and this last one will be the minimum requirement. So what we want to know is the units. How much of each should we give? So X and Y. And now we're going to look at protein. That food A has 2 grams of protein. Food B has 6 grams of protein, and we need a minimum requirement of 30. Now we'll look at fat. And here we have 4 grams of fat, 2 grams there, and we need 20. And then our last column is for cost. Food A costs 18 cents, so $0.18. and food B $0.12. And we want to minimize our cost. So we'll write that function first to minimize the cost. Z equal to 0.18x plus 0.12y, and we want to minimize. Okay, so that takes care of this column. Now let's look at protein. We're going to have 2x plus 6y has to be at least 30 grams. And for fat, we have 4x plus 2y has to be at least 20 grams of fat. Now we do have one other condition here. They said because of contract consideration, we got to have at least 2 units of food Y. So we'll just write Y has to be greater than or equal to 2. Okay, because of that, we don't need to say that Y has to be a positive number. Y has to be 2 or more. Okay, and we will write that X has to be greater than or equal to 0, because even if we use no food, we can't have a negative amount of food from X. Okay, so there's our inequalities and our function. So let's look at some of these. Okay, this time I'm going to make each box worth 2. And I'm still going to reduce this by a factor of 2. So I have x plus 3y greater than or equal to 15. 2, 4, 6, 8, 10, 12, 15, 14, 15. There. If I had no y, there would be 15 grams of x, or 15 units of x. If I had no x, I would need 5 units of y. So 2, 4, 5. And there's that constraint. Now this one I could also divide by 2 and have 2x plus y greater than or equal to 10. Well, if x is 0, then y would be 10. 2, 4, 6, 8, 10. If y was 0, x would be 5. 2, 4, 5. So that constraint looks like that. And if y has to be greater than or equal to 2, that line would come about there. So we have an open area now, which is fine because we're trying to minimize cost. But we need to know where these points are. Okay, obviously this point has a y-coordinate of 2. But let's look at what that means. If there's a y-coordinate of 2, we'd have 2x plus, this would have to be 12 equal 30. So 2x equals 18, and x is 9. So this point is 9, 2. Okay, for this point, I need to look at the red and the blue inequalities together. And I'm going to take that blue inequality and multiply it by -2. I have negative 4x minus 12y and negative 60. And then my red inequality, which I'm going to use as an equation, 4x plus 2y equals 20. When I add those together, negative 10y equals negative 40. So y must equal 4. And if I put that, let's put it here. If y is 4, then 6y is 24. So take away 24 from both sides, and I have 2x equals 6, so x must be 3. So this point is 3, 4. And then last, I have my corner point up here. And we know that that had a y-intercept of 10, so this is 0, 10. So now I've got my corner points, and I'm looking to minimize cost. So put this up here again a little bigger. Okay, for my first point, 0, 10, put a 0 here and a 10 here, and z is 1.2 at 0, 10. Now I'm going to look at the point 3, 4. So 3 times 0.18 would be 0.54, and 4 times 0.12 would be 0.48. So that's 0.9, 0.12, so 1.02. Okay, so this is smaller than that, but we need to check the 9.2 point still. So at this point, we've got 9 times 18, 0.18, so 1.62. Well, I can see already that that's not going to be the minimum because it's already bigger than this. But let's work it out anyway. 2 times 0.12, so 0.24, and this is 1.86. So since I was looking for the minimum, I found it here. 3 x's and 4 y's. It's going to give me my minimum cost. So pause the video now and work on checkpoint 2. Our last example is about investing. and balancing risk against the ability to make some money in an investment. This is a long one, so just bear with me as I read it to you. Mariana wants to invest up to $5,000 in stocks. The share price for CVS Health Corporation is $81, and the share price for Target Corporation is $57. Based on the average of 10-year returns, CVS would produce in a year a profit of $11 per share, and Target would produce a profit of $4 per share. Mariana would like to obtain at least $520 in profit. A measure of risk for each of these stocks is the beta value. The lower the beta value, the less risk associated with that stock. If the beta value for CVS is 0.62 and the beta value for Target is 0.24, how many shares of each stock should Mariana purchase to minimize the risk as measured by the beta value? So let's get started on a table. We're going to be looking at CVS and Target, our two stocks. And then we have constraints here. Number of shares is what we're trying to find out. So we'll just call those X and Y. Our next column will be cost. Okay, CVX costs a little bit more, $81 per share. Target, $57, and Mariana has $5,000 to invest. Our next column is for profit. $11 a share here, $4 a share here. We want to get at least $520. And then the risk, 0.62, 0.24. This is going to be our Z function. When you're reading the problem, think about what they say you want to have the minimum or the maximum of. In this problem and the feed problem, we want to minimize the cost for the feed. We want to minimize the risk for the investment. So look at that in the question. When you're setting up your table, what is it you're trying to minimize or maximize? And what is it you're trying to find out? Okay, I want to know how many shares of each should I buy? Or should Mariana buy? So let's write some inequalities. Okay, I don't have any constraint on how many shares I can buy, but I do know that 81x plus 57y has got to be less than or equal to $5,000. That's all the money I've got. And now for my profit, I have 11x plus 4y, and I want that to be at least, so greater than or equal to $520. Okay, and my Z function is going to be the risk, so 0.62x plus 0.24y. And the risk is something we want to minimize. So looking just at the risk, I say, well, I want to buy as much Target as possible, but Target doesn't make as much money. So to meet my goal of 520, I'm going to have to buy some of the CVS as well. I didn't say it, but it only makes sense. X and Y both have to be greater than or equal to 0. I can't buy negative shares of stock. So we'll just stay in this first quadrant. Okay, without going through all the specifics, I'm going to show you two lines because these are really off the scale. But my two lines will look something like that. And this is my feasible region. And the corner points involve a lot of calculation here. That they are 47.3 and 0. That's this one. This one that's out a little further, 61.7 and 0. And then we've got this top point, and it's at 31.8 and 42.5. Okay, now I hope that you can see with this point and this point, since the y is 0 on both of them, it's just going to be 0.62 times these two numbers. And so this one is going to be less, since it's a smaller number. And it actually comes out to 29.236 when I multiply the 0.62 times the 47.3. Okay. This one comes out nearly 40, so I won't do that calculation. But now we need to look at this one. When I put it in this equation, I get 29.916. So very close between here and here, but this one is a little bit less. So what does this tell us? Is that I should buy all CVS and no Target. It's a lot lower risk, but it just doesn't make enough money to meet my earnings goal. So let's pause the video now, work on checkpoint 3, and then move on to your homework assignment. So that's the end of this lesson. You should be ready now to work some of these type of problems on your own in your homework assignment.